Your dashboard is late because the warehouse is locked. The pipeline seems to be working just fine, right up until a backfill melts the entire cluster. Sound familiar? Yeah, these are the real failure modes of modern data pipelines. So today, we're going to move past the clean diagrams and get right into the messy, operational reality of how these systems actually run at scale. Okay, let's get into it.
And that right there is the most important thing to remember. The diagrams we all see in blog posts, they look so clean, so simple. But in production, this thing is a living, breathing system. It's got retries, locks, backfills, and a whole lot of ways it can fail. The real complexity isn't in the boxes and arrows, it's in the operational discipline you need to keep it stable when things get rough.
So here it is, the entire reference architecture in one shot. Let's follow the data's journey. It all starts with producers, which create events. Those events flow into Kafka, our durable log. From there, the data gets landed in S3. That's our raw, completely untouched data lake. A metadata layer, like Glue or Hive, then makes all that data discoverable. Next, a transform layer gets it ready for our Redshift data warehouse, where it's tuned for super fast queries. And finally, you've got the BI layer where your users actually get their hands on it. See? Each layer has one job and one job only. So here's our game plan. We're going to start with a deep dive into each of those 7 layers to see how they tick. Then, we'll talk about the modeling strategy that keeps you out of the data swamp. After that, we get to the heart of it, the real-world failure modes and war stories. We'll wrap things up by looking at performance and cost, key operational practices, and the final takeaways you can put to work right away.
All right, let's get into the mechanics of this. For each layer of the pipeline, we're going to look at what its job is, what it absolutely should not be doing, and one of the most common ways we see it break in the wild. This separation of concerns is really the secret sauce that makes the whole thing work.
Let's walk the line, starting at the source. The producers, they own the event schema. Their job is not to do heavy transformations. The classic failure? A silent schema change that poisons everything that comes after it. From there, events hit Kafka. It owns durable, ordered buffering. It is not a long-term data lake, and its textbook failure is consumer lag that builds up quietly until suddenly it's a 5-alarm fire. Next, the storage layers. S3 is for raw, immutable storage. It's not a query engine. Its silent killer is the small files problem, which just murders performance over time. To make that data useful, the metadata layer owns the schema and partition info, not the data itself. A common failure here is when partitions don't get updated, making new data completely invisible. Then we get to processing. The transform layer owns the ELT logic. It should never, ever bypass the lake. And it often fails with logic that isn't idempotent, creating nasty duplicates on retries. And finally, we have the layers where users feel the pain. Redshift is for fast queries on curated data. It is not a dumping ground for raw JSON. And the BI layer owns presentation, not heavy lifting. Let's see how those last two can create total chaos together.
Okay, now this is where it gets really interesting, the tension between the warehouse and the BI layer. In production at iHeartMedia, we live this. You'd have a materialized view refresh in Redshift chugging along for 10, maybe 12 hours, locking tables the whole time. And what's happening simultaneously? BI dashboard queries are hammering those exact same tables, trying to read data. This contention, this fight between ETL writes and BI reads, is a silent killer of your pipeline's performance. It delays your data loads, it causes jobs to fail, and it can grind the entire cluster to a halt. This is exactly why that separation of concerns is so non-negotiable.
And all this talk about layers and separation brings us to a super critical topic, data modeling. Because without a disciplined strategy, your beautiful data lake quickly turns into a messy data swamp, and your warehouse becomes absolute chaos. The goal is to have a clear, predictable path for data to move from its rawest form into something highly valuable for the business.
The industry standard for this is the medallion architecture, bronze, silver, and gold. Think of your bronze layer, which lives in S3, as your source of truth. It's the raw, untouched data, exactly as it came from Kafka. You never, ever, ever change it. Why? Because it guarantees that if you find a bug down the line, you can always replay history from a perfect source. The silver layer is where the magic starts. You clean the data, you deduplicate it, and you can form it into reliable, queryable base tables. And finally, the gold layer. This is your trophy case. It contains your highly aggregated data marts, purpose-built to power specific BI dashboards. They're small, fast, and totally business-ready.
So the key here is discipline. Your raw or bronze layer is just for immutable events. It is your ultimate safety net. Your curated or silver layer is for those clean base tables. This is where you handle tricky stuff like late arriving data, maybe by having a look-back window where you reprocess the last day or two to catch stragglers. And your marts, your gold layer, are just for those dashboard-ready aggregates. Any schema evolution, like adding a new column, has to be handled gracefully, starting from raw and flowing through. Remember, adding a column is usually fine. Renaming or removing one, that's a breaking change that needs a whole lot of coordination.
Okay, now for my favorite part. The part most tutorials just skip. We've seen the clean diagram. Now let's talk about how it really breaks. Forget the elegant architectural debates. Production failures are about locks, overloaded clusters, and good old-fashioned operational mistakes.
A typical incident? It almost always follows the same script. The symptom is a user on Slack saying, "Hey, the data's stale." So you start digging, and you find the root cause. Maybe Kafka consumer lag has been creeping up for hours, or maybe a long-running BI query is blocking your ETL loads in Redshift. You detect this with good monitoring. You get an alert on lag, or query queue times, or lock waits. Your immediate fix, the mitigation, is to kill the query or scale up your consumers. But the real work, the prevention, is implementing better workload isolation or back pressure, so this exact thing doesn't happen again next week.
Now, what's really fascinating is what breaks first when you're running this at a massive scale. Based on our experience at iHeart, it's not some exotic fundamental architectural flaw. Nope, the pipeline breaks because of the daily friction of running a complex system that everyone is trying to use at once. It's the operational stuff that gets you.
And this slide right here is basically the greatest hits of production fires. We've already talked about those painful MV refreshes and lock contention, but what else? Oh, treating a backfill as just another routine job instead of the high-risk operation it is. That's a huge one. It will overwhelm your system. The small files problem in S3, quietly killing your query performance. A producer making a harmless schema change that breaks everything. And of course, the classic, giving analysts self-service access without any guardrails and watching them accidentally melt the cluster with a bad query. These are the boring but absolutely critical realities of the job.
Every single one of those performance issues has a $ attached to it. So a huge part of running this kind of pipeline is actively engineering for performance and cost. Let's follow the money and see where you can actually make a difference.
This right here is one of the most important lessons for any data engineer. So listen up. Storage is cheap, compute is expensive. Your S3 bill might seem big, but I guarantee you it is dwarfed by the cost of your Redshift cluster and all your ETL jobs. We saw this in production. The vast majority of the budget, like 85% of it, goes to compute. So the single biggest lever you have on cost is optimizing that compute. And the best way to do that is to simply scan less data.
So how do you actually reduce those scans? It comes down to two sets of guardrails. First, your S3 data layout is critical. You have to use a columnar format like Parquet. You have to partition your data by date. And you have to aggressively fight that small files problem. Batch up your writes so you're aiming for files well over 100 megs. Second, inside Redshift, you must set proper distribution and sort keys. And critically, you have to use workload management, or WLM, to isolate your heavy ETL jobs from all the ad hoc BI queries. Don't let them fight over the same resources. This all leads us to the day-to-day discipline of it all. You can have the best architecture in the world, but with poor operational practices, it's going to fail. So how do the best teams keep a complex system like this running reliably?
Well, it really comes down to these 5 pillars. First, smart orchestration. Use sensors and airflow to wait for data to actually land before you kick off a job. Second, and I cannot stress this enough, idempotency is non-negotiable. Your jobs have to be rerunnable. The classic pattern here is a transactional delete and write. Third, treat your SLAs and backfills with the respect they deserve. Backfills should be run in small chunks in reverse chronological order. Fourth, observability. You have to monitor Kafka lag, data freshness, row counts, and warehouse locks like a hawk. And finally, change management. Schemas are contracts. Use a schema registry and treat any change like a formal API version bump.
Okay, let's bring it all home. Building these pipelines is all about making a series of trade-offs. And maybe the biggest debate you'll hear today is about streaming versus batch. So let's talk about the truth in production.
Despite all the hype you hear, pure record-by-record streaming is rarely the right answer for analytics. The reality is, for most BI and reporting use cases, a 5 to 15-minute latency is totally fine. An approach like micro-batching, where you process data in small regular chunks, gives you that near real-time feel without the massive operational complexity and cost of a true streaming system. For analytics, batch is still king because it's simpler, cheaper, and a heck of a lot easier to debug.
So after all of that, let's distill this down into the 10 most critical takeaways for building a pipeline that actually works in the real world.
Number 1, say it with me. Storage is cheap, compute is expensive. Optimize your scans above all else. 2, small files in your data lake are the silent killer of performance. You have to compact them. 3, warehouse contention is real and it will happen. You have to isolate your BI and ETL workloads. 4, schemas are contracts. Use a schema registry to enforce them. And 5, backfills are high-risk incidents, not routine tasks. Plan them, throttle them, and monitor them closely.
6, your jobs must be idempotent, period. They have to be rerunnable without messing things up. 7, ELT, extract, load, then transform in the warehouse, is the modern standard for a good reason. 8, microbatch is the pragmatic choice for analytics. Use true streaming only when the business case is absolutely undeniable. 9, a simple, debuggable system will always beat a clever, complex one in the long run. And finally, number 10, never, ever bypass the data lake. S3 is your immutable source of truth. It is your ultimate safety net.
So I'll just leave you with this one question. You might get your pipeline to a stable state, but is it observable? If you can't measure its vital signs, the freshness, the volume, the query patterns, the lock contention, then you are flying blind. Because a pipeline that isn't observable isn't truly stable. It's just waiting for its next silent failure.